teach it yet. Let me just go over it. I'll go over the front page, then I'll come by and mark off the homework. Sound like a deal? So scientific notation, just so you know, it's either used to represent really large numbers and make it a workable thing. And scientific notation was used a lot more before calculators could go, further out than 9 decimal places back in the olden days. And then it's also used to represent very, very small numbers, like decimals that are 0.00, forever small. And so, scientific notation was used. It's a way to go through and figure out numbers. You don't worry about the ones, tens, and hundreds places really in scientific notation as much because they don't, when you're talking about trillions of miles, a mile or two doesn't make a difference. Okay, so first one talks about they wanted you to make the speed of light into scientific notation. So they said that was 186,000, right? So when we do scientific notation, you want to make it kind of look like this. Okay? And so there's where the blanks are, you're going to put some information. So let me ask you this. Where does the decimal exist right now on 186,000? Where is it sitting? Behind the zero. It's sitting right here. Does everyone agree with that? Everyone probably should know that. I would imagine. I get the hiccup. Excuse me. All right, so I'm going to move this decimal. 1, 2, 3, 4, 5. Okay? So then I'm going to go to 1 here. So the decimal, see how the decimal? 8, 6. I'm not worried about the rest, but I moved it 5 places. So that's how you would represent 186,000 as scientific notation. Yeah?
Don't you have to get, the number in between, 1 and 10? Or 1 and 5 or something like that?
What number?
The 1.86 part. Doesn't that have to be between, 1
Yeah, you want this to be a single, single held place. You don't want it to be 18.6. You want it to be 1 point, or 7 point, or 9 point. Okay? Yeah?
Couldn't you also say that you could do 186 times 10 to the third power? Because the decimal could be at the end of 186.
Ooh. Okay, so that would be writing it as an exponent and not in scientific notation. It's a good thought. I like it. Okay, and I'm actually going to show you something on the calculator that will probably answer that question a little bit better, but I have to wait till I get to a larger number. So I'm going to hold off on answering the rest of that for a moment. Is that okay? You'll see it. Yeah?
So, would it be, how come it's not negative?
Okay, yeah, because it's a large number. If this was a decimal, which we're going to get to, so this next one, talking about angular velocity, number 2, they give us it as 0.0036. Okay, so remember as I write scientific notation, I want it to be like this, where I'm putting into the blanks. So you see the decimal on this one, right? It's not resting behind the whole number. So I'm going to move this here, 1, 2, 3. Okay, so then I get 3.6. I could put 3.60 if I wanted to. I don't need to. And then I move 1, 2, 3. So that's a -3. And that indicates you're talking about a small decimal.
So if there's no decimal?
If it's not, so the difference between the two, this was a relatively large number, so that's going to be an exponent that's going to be a positive exponent. If it's a decimal you're converting back, if it's a decimal where it's like 0.0000, it's going to be a negative exponent. Okay? All right. And then number 3, they have this as 2 raised to, and this is an exponent, 2 raised to the 64th. Okay? Now this is where I'm going to talk about what you had talked about. That's exponential form. That means you're taking 2, you're multiplying by itself 64 times. Okay? It's kind of hard to count like that. So I'm going to bring up the calculator real quick, and I'm going to show you this on the calculator. Okay, I'll close that. I want to do 2 raised to the 64th power. Okay, that's what that one says. And we're going to put this in scientific notation. I think that'll allow you to see how it's a little bit different blushing. Okay? Enter. Does any, yeah.
Doesn't that essentially mean you add 19 more zeros after the e?
Yes. Exactly. Okay, so 2 to the 64th power, if you look up here, you notice there's an e up there. That e doesn't stand for error. That's the calculator's way of doing scientific notation. Okay, so let me see if I can do this. I'll try and do this right. Go here. And here. This should allow me to write on it. So, 2 raised to the 64 power is 2 times 2 times 2 times 2, keeps going and going. Which is going to be 1, whoops, I did convert it. I know I did. Right. Okay. Let's do this. 1 point, what was it? 84467. 84467. And then there's an e there to the 19th. Okay? So what this converts to it to make it sign, this is how the calculator recognizes scientific notation. I don't know why it doesn't recognize it as you see it. So we already have the blank, boom, boom, boom. Okay, we don't have the times 10 to the, but the 19 is going to go there. And I'm going to use the first 3. So I have 1, that's there. 8, 4 times 10 to the 19th. So 2 to the 64th power is a huge number. Meaning, if I were to convert this back to what the number is approximately, I won't be able to see the number exactly from scientific notation, but if I were to convert this back, this means this decimal is going to move this way 19 spots. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oops. 1, 2, 3 there, 1, 2, 3 there, 1, 2, 3 there, 1, 2 there, 1, 2 there. Millions, billions, trillions, 100 millions. So that is 18 billion trillion. Yeah, it's big. It's a big number. Did I go too many? So, all right. So that's how you would convert that. So you'd use this, use the calculator to find that, and then it gives you that is the calculator confirms it, make it look like that. Then you take the first number, the next 2 numbers, times 10 to the whatever after the e is.
Wait, but why don't you put the 4, 6, 7?
Because you're talking about an extremely huge number.
Yeah.
Okay, so it'd be like this. Let's say I gave you $1 million right now.
I'd like that.
Okay, but let's say I say, well, I have 2 pennies. Does that 2 pennies really mean that much in comparison to $1 million? No. That's kind of why you kind of start truncating things off.
Okay, so you only have like the 1 point and then the 8, 4, so you only have like 2 spots after the decimal.
Yep.
Okay.
Because in scientific notation, you're talking about extremely large numbers or extremely small numbers. Extremely large numbers, the billion trillion, if this was like 22, you're talking about such a negligible small part of the number that it doesn't make a difference, and it's not accepted in the science community. Okay? All right. All right, so then they talk about, number 4, they talk about the radius of the moon. And they already gave it to you in scientific notation. Now, this one, they actually have it out 3 spots, which is, I don't think you necessarily need to have it out 3 spots. The reason they have it out 3 spots, I think, is so you realize this. Okay, if I were to convert this, decimals here, I'm going to go 1, 2, 3, so it's this. Okay? So that's the radius of the moon when it's not in scientific notation. Okay, I don't think I would leave it at 3 spots. I think I'd go 1770, but it is where it is. Credit card interest per day, they say they have 1.3 times 10 to the negative 2. Okay, so it's a negative exponent here. Here it was a positive exponent, so I moved my decimal to the right. Here it's a negative exponent, so I'm going to move this to the left. 1, 2. So now my decimal's here. So what has to be my placeholder there is a 0. So I get 0.013. So I moved the decimal 2 places to the left because it was a negative exponent. And then Peyton Manning's salary. Okay, I don't know if this is real or not. They're just trying to make it so it's like, oh, just like home. Just like home. You know, I know Peyton. All right. If I was to convert this, how many places do I have to move the decimal to the right?
7.
And why am I moving it to the right and not to the left? Because it's a positive exponent, right? So I get 1, 2, 3, 4, 5, 6, 7. So old Peyton was making $18 million a year. I don't know if that's true or not. I'm just saying it's a lot of money. A lot of money, but good for him. That's okay. So is that okay? So now you are up through basically number 6, and let me come by. I want to come by and I want to mark off your pages because I was hoping you'd get 7 through 20 done. That's something. All right, let's run over that backside, if you don't mind. All right, so page number 6 on the backside. Let me read the answers. I'll do 4 in a row, and then if you have any questions, I'll work those out, okay? All right, so problem number 7, the answer is x to the 6th, y to the 3rd. Problem number 8 is 2 to the 4th, c to the 12th. I could probably convert 2 to the 4th to 2, 4, 8, 6. So that could be 16c to the 12th. Okay, if you left this 2 to the 4th, I'll call it good, okay? Problem number 9, the first step, you get it to v to the negative 6, which is the same thing as 1 over v to the 6th. Number 10, I get 9, b to the 8th, a to the 6th. Are any of those 4 you want me to work out? Yeah. 10? Got it.
Yeah, I didn't get any of that.
Okay. What? No.
Or at least 9.
Okay. Okay. Everyone agreed there's power to power up here. We also have negative exponents. So we have to start someplace. So we can either start with the negative exponents or we start with the power to the power. It doesn't matter. I'm going to start with power to power. So this 2 comes here and this 2 comes here. So I'm going to get 9b to the negative 4. I'm going to stop there for a moment. Is that okay? I have a negative exponent. There's got to be another step to this eventually. Okay, then I'm going to do power to power here. So here and here. So I'm going to get a to the 6th, b to the 8th. Is that okay?
B to the 8th.
Power to, oh, b to the 12th. Thank you. Is that okay? Seem okay? All right. So I have a negative exponent. This is the only thing that needs to move down. So I'm going to get 9, a to the 6th, b to the 12th, over b to the 4th. Agree? Tug of war take place, yes? So who wins, top or bottom on the b's? Top by how many?
8,
Here's your answer.
9, oh wait, hold on. It's 9, 6,
You wanted to see number 9 as well? Okay. Hold on. Everyone go? Good? Number 9, we have b to the negative 2 to the 3rd. Okay. Power to power, exponents on top of each other, they multiply. That gives me v to the negative 6. Everyone agree? I don't want a negative exponent. So right now that's a numerator. I can put it over 1. Okay? This is going to move down. Done. Okay? Yeah.
Number 18.
I haven't even gotten there yet. I only did that up through 10.
Okay.
Slow down there, Tiger. All right, number 11. That 2 distributes to both the 3 and the 8, so you get 3 squared over 8 squared. 3 squared is 9, so you get 9 over 64. You could have left it 3 squared over 8 squared at this point. Number 12, that 3 distributes to everything, so 2 to the third, p to the third over 5 to the third. 2 to the third is 8, so I could have 8p to the third over 125. Number 13, distribute that 5 outside to both, power to power. So I get x to the 20th over y to the 10th. Number 14, if I distribute that negative 3 in, I'll wind up with x to the negative 12 on top over y to the negative 6 on bottom. They both want to switch locations, so your answer will actually become y to the 6th on top over x to the 12th. Anything up through number 14 you'd like to see? Yeah. 11 and 12, yeah. Number 11 and number 12. Okay, this one, that goes here and here, so that's 3 squared over 8 squared, which is 9 over 64. And then I can do this one here. It goes here, here, and here. So I get 2 to the third, p to the third, over 5 to the third. 2 to the third is 2 times 2 times 2, which is 8. P to the third stays as is. And 5 to the third is 5 times 5 times 5, which is 125. We good? No? Do what? I'm going to get there. I'm going to get there.
He's not on that row yet.
All right, so now let's just do this. 15. 15, I have x to the negative 1 over y to the 5th. The whole thing's raised to the 3rd. So that's going to give me x to the negative 3 over y to the 15. Do you agree with that so far? Okay. X to the negative 3 is negative exponent. Someone wants to move down. If everything moves down, what has to be a placeholder? If this moves down, what do I have as a placeholder? I get a 1. Done. Okay, so that's the answer there. 16.
Oh, wait. Oh, never mind.
Is there?
Oh, thank you.
16. We have 2xy to the 5th times 3xy to the 4th squared. Okay, quick question on number 16. Let's take a look at this first grouping here. Is 2 going to be raised to the 5th power on this one?
No,
Why not?
because it's not within the parentheses.
Good. It's not within the parentheses. So this 5 is going to distribute here and here. So I get 2x to the 5th, y to the 5th. Does everyone agree with that? Okay. Now, on this one, I get 3 squared, x squared, y 8. Y is 3 squared on this one. It was in. It was grouped with it. Okay, so now we're going to do the arithmetic. It looks like I don't have any negative exponents. So what is 3 squared? 9. 9 times 2 is 18. Is that okay so far for those? Like bases when multiply, I'm going to add the exponents. I'm going to count them up. So I'm going to have x to the 7. Like exponents, like bases when multiply, I'm going to count up the exponents. And it looks like that. Okay. Can I move off that one? I don't think I can do this too. Let's split the screen. So there's 16. 17 is, we have x to the 4, y to the 5 over x to the 7, y to the negative 2, and that's to the negative 3. Okay, we have negative exponents. We have power of a power. We have same bases on top and bottom. This is where a lot of students start getting into a little trouble with it because they want to do too much in their head. And I get you want to do a lot in your head. It's awesome, but this is not a place to show off with that. this comes here, comes here, comes here, and comes here. So I'm going to get x to the negative 12 on top. I'm going to get y to the negative 15 on top. I'm going to get x to the negative 21 on bottom. And I'm going to get y to the positive 6. Does everyone feel comfortable with power to power where I distributed that negative 3 to all of it? Does everyone agree things need to move? Does everything move? No, what doesn't move? Y to the 6th, right? So let's move everything first before we go a little further. So this is going to move, this is going to move, and this is going to move. Okay, I'm going to go to the screen on that. Nope, that's not what I wanted. I wanted to go to single page. All right, so that's what we got going so far. Gosh, really enlarge that. All right, so let's move what we need to move. So it looks like x to the 21's on top over x to the 12th on bottom, y to the 15 on bottom, and y to the 6 on bottom.
Can you connect the both y's?
Yeah, we're going to. Okay, tug of war with the x's. Who wins, top or bottom? Top by how many? 9? Is that right? And then is it tug of war with the y's or combined? Combined. Okay, they're not top and bottom. So that's going to be y to the 21. Like bases, add the exponents. All right. Split screen that bad boy. Display. On over. So it's right there if you need to see it. Number 18. That's number 18. Everyone done with it? Still looking at 17? Good. All right. All right. On this one, this 7's going to go here and here. This negative 3 is going to go here and here. So again, let's not try and do too much in our head. So I'm going to get x to the negative 14, y to the 21st, x to the negative 9, y to the negative 12. Are there some things that need to move? Are there some things that stay where they're at? What stays where it's at? Y to the 21st. Everything else is going to move. So I'm going to get x to the 9 on top, y to the 12th on top, y to the 21 was already there. And then that's going to be over x to the 14.
Excuse me, I got it for like, I got x to the 21st and then y to the 28th for the bottom. Like, for like the first one that you did. Because like it was,
I distributed negative 3 to negative 4, or to 4, right?
never mind.
All right.
Never mind.
Tug of war with the x's. Who wins, top or bottom? Bottom. Is the y is going to be a tug of war or combined? Combined, so I get y to the 15th. Done. Number 19. Right? Oh, do you guys need me to really do number 19? Anyone know what the answer is? 1. You have that whole grouping to the 0 power, right? It's just 1. That's it. And then we'll do number 20. Number 20. Give us a whole worksheet of those. I'll get the whole thing right. Good for you.
I probably get it all wrong.
So like the test, I was like, oh
All right. Let's see. I have a negative exponent, right? So that x wants to move down. So I'm going to combine those together. That's going to give me 16. Then I have x squared, y to the third, y to the 11, all over x to the 10th. Is that okay? Where did the 16 come from? I multiplied 2 times 8. They were both bases. Didn't have any exponents. Tug of war with the x's. Bottom's going to win by 8. Combine the y, so I get y to the 14th. There's my answer. We good? All right. Make sure your name is on those and pass that forward, please. And if you would, get out page 7 for me. If you would, get out page 7. We're just going to work directly on page 7, okay? Yeah, but I'm going to go over a couple of the problems on page 7, so it's going to lessen your amount. Okay, so do you have page 7 out? Okay, I'm going to look at problem number 10 on page 7. We're going to treat problem number 10 on page 7 just as kind of your notes. Okay, so just so we know, we're trying to get our answer to be like this. We're trying to get to that, okay? All right, so this is how we're going to work these problems. Ready? 6 times 7. 42, good. Times 10 is your base. Like bases being multiplied together. What do we do with the exponents?
You add them.
So I add them. Okay? So 42 times 10 to the 16th power. Okay? So now I want to put this. So where does the decimal exist in this answer right here? Not yet, not yet.
But after the 2.
It's right here. This is where the decimal lives right now. Right? But I want to put it here. I want this to be 4.2. I could put a 0 there if I wanted to. Okay, for my placeholder. Okay, so now we have to think about this. So I'm going to do a little side note. If I have 42, if I made this in scientific notation, that'd be 4.2 times 10 to the first. Agree?
Why the first?
Because 4.2 times 10 is 42.
Oh.
Okay. So we need to somehow, so I just had modified just that little part right over here for a second, just as a thought process. So if I move the decimal to the left, which I did here, because it was here, I moved it here. What is my exponent going to be? Is it going to be a larger number? What would it take for me to move it to the right? I just did it right here. If I wanted to move this decimal to the right, I multiply times 10, right? Is it a bigger number or a smaller number? If I move my decimal from here to here, it's larger, so it has to go to the 17th. Okay, so this had to increase because we had one decimal place. Okay, and you're not going to see a whole plethora of that, but we're going to So that's how number 10 is done. If you notice, number 9 and number 11 are just like number 10. Nice thing on number 9, you multiply 3 times 2, you already have it as 6. So you don't have to go, goof things at the end. Okay, so now I want to look at problem number 13. Is that okay? Okay. May I move off this screen? Number 13. I have 2 times 10 to the third over 8 times 10 to the negative 2. So I kind of want to break this apart. I want to break this into some clumps. So I have 2 over 8. What does that reduce to? 1 over 4. 1 over 4 as a decimal is what? 0.25, right? Does everyone feel comfortable with what I just did there? I just looked at this part of it only. And I realized that is going to be the same thing as 0.25. Is that okay? All right. Now, I can't do tug of war with them right now. For what reason? You have the negative exponent. So what's that negative exponent going to do to that 10 on bottom? It's going to move to the top. So 10 to the third is content where it's at. Now it's going to be joined by 10 to the second. Why is it now 10 to the second? Where did the negative go? It moved up. So this is moving up. So you get that. Now, like bases, what am I going to do with the exponent? Add. So that's going to give me my 10 to the fifth, okay? So now we have to move down here. So I have 10 to the fifth. But this is not in our true scientific notation. Why? Because it's 0.25. I want to now modify this to be 2.5 times 10, and our exponent is going to change. This has to change to something. 6? So let me ask you this. What would, if I were to move my decimal 5 places this way, go. So this number right here, this whole number, if I convert this back, is, so 1, 2, 3, 4, 5. Agree? So I want the decimal to be right here, right? The decimal's right here because we moved it. So if I move 1, 2, 3, 4.
So, like, if that happens and you have to move the decimal point, you have to go down 1.
And that's the magic right there. All right, so a couple of things that we'll talk about. Is everyone okay with this? It's a little different, so it's going to be kind of goof your mind up a little bit. So a few things that we need to know. Okay, on Schoology, I have a small little matching. We're going to call it a quiz, but you get to do it at home. Okay? It's under the second semester folder. Okay? So go in the second semester folder, you're going to see that little puzzle piece. Okay? I think it's 9 problems, and you're just matching up the answer. So it's like, oh, okay, problem number 1 goes with answer D, or something like that. Okay? It's worth 4 points, and I will put it in. It is due. This is due Monday night. So this coming Monday, we don't have school Monday, at 11:59 p.m. Okay? It should be pretty quick. Don't just blow it up going, I'm just going to guess and hope for the best. No. I mean, the nice thing is I would like to get a 4 out of 4 quiz score in for all of you right up front. Okay? So that's first thing that I need you to know. That is there for you to work on. And then I would like you all to do pages 7 and 8 for also homework. Now, we already started a couple of those, but that'll be for homework, okay? Now, as far as your packets go, we will have one more page left, right? So page 7, 8 is good, and then you have page 9 and 10. So after Tuesday, what happens after Tuesday? Yeah, you better have gone over to Bare Necessities and got your book. Okay? If you didn't, you're going to start missing out on the homeworks because it's there for you. And again, if you can't afford it, don't tell us. Go talk to your counselor. The counselor will give you a little coupon that'll allow you to go to Bare Necessities and get the book on us. Okay? But it's $5. Did anyone get it yet? Blue cover, right? Okay, yeah. And then again, you get, guys and girls, you can get rid of anything from last semester you want. You don't need to walk around with it. We're not going to be referring back to it. Yes, there are skills that we learned last semester that we'll be applying this semester. Are you really going to flip back going, oh, how did I do that? Or are you just going to ask? You're going to ask. So, makes you normal. Okay, so 2 things for homework, yes? Something on Schoology and page 7 and 8. You have the next couple minutes. If you wanted to get a little bit of that homework done on that page 7 and 8, go for it. Other than that, that's all I got. First week of CP Algebra 1 is down for the semester. Only 17 more to go.